Hi students, today we are going to discuss the topic interference of light, which is a consequence of the superposition of light waves. You look at this diagram, there are two sources S1 and S2 from which light waves are traveling forward and they superpose at a point P which is lying on a screen. Now the source S1 is emitting light waves of amplitude A1 and S2 is emitting light of amplitude A2, but when they superpose at the point P, the point P may be bright or dark depending upon whether constructive interference of these two light waves takes place or destructive interference of the light waves takes place. So at the point P, there is a modification in the intensity of light. This modification in the intensity of light due to the superposition of two light waves is called as interference of light. Okay. Now the displacement of the light wave emitted by the source S1 is given by y1 is equal to a1 into sine of omega t, and the displacement of the light wave emitted by S2 is given by y2 is equal to a2 into sine of omega t plus phi, where phi is the phase difference between the two light waves. So one wave may start earlier than the other one or little later than the other one. So this phase difference is represented by the angle phi, phase angle phi. Now at any point like P, when the two waves are superposing with each other, then what will be the resultant displacement of the two waves? That is from the principle of superposition of waves given by y equal to y1 plus y2. Now I am going to substitute for y1 equal to a1 into sine of omega t. So a1 sine omega t plus a2 into sine of omega t plus phi. So now only mathematical steps are ahead. So I am going to expand this. So first term is a1 into sine of omega t plus a2 is taken out, and sine of omega t plus phi is in the form of sine of a plus b, whose expansion is sine a cos b plus cos a sine b. So I am going to expand this. So the first term is sine of omega t into cos phi plus cos of omega t into sine phi. Then I am going to multiply this factor a2 with these two terms. So we can write y. So y is now equal to, therefore y is now equal to a1 into sine of omega t plus a2. The first factor is sine omega t cos phi. So this is sine of omega t into cos phi plus a2 multiplied by cos omega t into sine phi. So this also can be written as sine phi into cos omega t also. So this is now equal to, you can see here sine omega t is common to the first two factors. So I am going to take them out. So this will become a1 plus a2 cos phi. So this is taken inside the bracket into the common factor is sine omega t plus, now leaving cos omega t, the remaining factors a2 into sine phi, a2 into sine phi into cos of omega t. Like this I have written. Now let this factor inside the bracket, okay? These two factors inside the bracket I am going to write like this. So capital A into sine theta is equal to, instead of this factor, a2 into sine phi, and this factor is a cos theta. So this a cos theta is equal to a1 plus a2 cos phi. I am going to substitute in the previous equation. Therefore now the resultant displacement y will be equal to this a1 plus a2 cos phi. a1 plus a2 cos phi is a cos theta. So this is equal to, instead of that, a cos theta into sine omega t. The remaining factor is sine omega t plus, instead of a2 sine phi, I can write a sine theta. So this is a sine theta into cos omega t. once again, A is a common factor. So this is equal to capital A into, I will rewrite in this form, sin omega t cos theta, sin omega t into cos theta plus cos omega t into sin theta. So into sin theta. This is also like a sin A cos B plus cos A sin B format. So this can be written as, therefore y is equal to capital A into sin of omega t plus theta, omega t plus theta. So like this I can write. Now what is capital A here? No, capital A is called the resultant amplitude. So capital A represents the resultant amplitude of the wave. So the resultant amplitude. Suppose if constructive interference is taking place, these two amplitudes A1 and A2 may be added up. So this may be capital A equal to A1 plus A2. Or if destructive interference is taking place, then the resultant amplitude may be A1 minus of A2. Okay. So this is the resultant amplitude. We are going to derive an expression for that. So here in this equation, A sin theta and A cos theta, whatever factors I have substituted, I am going to square on both sides. I am going to square on both sides. So now you take here, this is A square. So this is A square into sin square theta. This is equal to A2 square. So this is A2 square into sin square phi. Similarly, this factor A square cos square theta. So this is A square cos square theta. Now this is equal to A1 plus A2 cos phi the whole square. So this is first term. First term is this is A1 square plus the second term is A2 square into cos square phi plus the third term is 2 into A1 A2 into cos phi. I have squared A1 plus A2 cos phi the whole square. So first term is A1 square, second term is A2 square into cos square phi plus 2 A1 A2 cos phi. Now I am going to add on both sides. I am going to add the left hand side as well as the right hand side. So what will be on the left hand side first? So when the left hand sides are added, you see here it is A square into sin square theta plus cos square theta. So I have added A square sin square theta plus A square cos square theta, and this is now equal to, first one is A2 square sin square phi. So this is A2 square sin square phi plus A1 square. So this is A1 square plus A2 square into cos square phi plus 2A1 A2 into cos phi. Now you can see here left hand side is sin square theta plus cos square theta is equal to 1. So I will take A square only on the left hand side. So A square into 1. So this is now equal to this term A1 square. First I will write A1 square. So this is A1 square plus here A2 square. Here also A2 square is there. Common factor is A2 square into sin square phi plus cos square phi is equal to 1. So this is sin square phi plus cos square phi plus 2 into A1 A2 cos phi. So this also will be equal to 1. Therefore A square is now equal to A1 square plus A2 square plus 2A1 A2 cos phi. Now I am going to take square root on both sides. Therefore now the resultant amplitude is given by capital A is equal to square root of A1 square plus A2 square plus 2A1 A2 into cos phi. So this is the main equation. So already we have got another equation here. The resultant displacement is given by y equal to capital A into sin of omega t plus theta, and now the resultant amplitude. So this is another main equation number 2. Have you understood up to equation 2? So the resultant amplitude is given by capital A is equal to square root of A1 square plus A2 square plus 2A1 A2 cos phi. Now we are going to generalize the case. That is, due to constrictive interference, the amplitude will be maximum, the intensity will be maximum, and due to destructive interference, the resultant amplitude will be minimum, so the resultant intensity also will be minimum. So I am going to write the two cases. So first one is for maximum amplitude. Okay. Now you see here, for maximum amplitude, what is the required condition? For maximum amplitude, cos phi in this bracket, no? So cos phi must be equal to plus 1, or phi must be equal to 0, or plus or minus 2 pi, or plus or minus 4 pi, etc. Okay. So what is the condition required for the amplitude to be maximum? So inside the square root you can see there is a cos phi term. If cos phi term is plus 1, or phi angle phi is equal to either 0 or plus or minus 2 pi, 4 pi, 6 pi, 8 pi, like that, it is even multiples of pi. So in this case only the amplitude is maximum. Therefore now we can write A maximum is equal to square root of A1 square plus A2 square plus 2A1 A2. Okay, so A maximum is equal to, so cos phi is equal to plus 1. Therefore A maximum is equal to this much, and this is now equal to square root of A1 plus A2 the whole square. So this is the expression for A maximum. Similarly, next one is for the condition for minimum amplitude. Okay, for minimum amplitude, so cos phi must be equal to minus 1, or phi must be equal to odd multiples of pi. Odd multiples of pi means plus or minus pi, plus or minus 3 pi, plus or minus 5 pi, etc. So in this case we can write, therefore A minimum is equal to square root of A1 square plus A2 square minus 2A1 A2. So that this is equal to square root of A1 minus A2 the whole square. So if you take this outside the square root, it will be A1 minus A2. Like that, if you take this outside the square root, this will be equal to A1 plus A2. So the amplitudes may be added up or they may be subtracted. Is it not? Suppose if both the amplitudes are equal, means what will happen? A1 plus A2 will become A plus A is equal to 2A, twice the individual amplitude. And A1 minus A2 will become A minus A is equal to 0. So the net amplitude is 0, net intensity is 0. So such point is called as a dark. Understand? Okay students, now the expression for A maximum and A minimum we have written. Understand? Okay. Now you see that the intensity is always proportional to the amplitude square, the square of the amplitude. So amplitude square. So now you can see here I is proportional to A square. So the resultant intensity is proportional to the square of the resultant amplitude. So what is this resultant amplitude you see here? I am going to write the square of this. So this is proportional to, or here itself I will write it is proportional to A1 square plus A2 square plus 2A1 A2 into cos phi. This is the resultant intensity. But now you take the intensity of the first one. The intensity of the first wave is proportional to the square of the amplitude I1 square for the first wave. And the intensity of the second wave is proportional to A2 square. Is it not? Therefore, I can write, therefore, resultant intensity is proportional to, instead of A1 square, no, I can write this is I1 plus I2 plus 2 into I1 I2 into cos phi. So this is very important equation for the competitive exams like the NEET and the JEE entrances. So this is very important equation. So I is proportional to I1 plus I2 plus this one is A1 A2. So I have to write this term is the square root of I1 into square root of I2. Is it not? Because instead of A1 square proportional term is I1. Instead of A2 square the proportional term is I2. So instead of A1 it is square root of I1. Instead of A2 it is square root of I2. Okay. So this is equation 3. Okay, now up to equation 3 you have understood, is it not? Okay. So equation 3 gives the intensity or the resultant intensity of the waves which has undergone superposition. Now maximum intensity is taken as I maximum. So I maximum is proportional to A square maximum, which is once again proportional to what? A1 plus A2 the whole square. So which is proportional to A1 square plus A2 square plus 2 into A1 A2, and hence it is proportional to I1 plus I2 plus 2 into square root of I1 into I2. Similarly, the minimum intensity I can write I minimum is proportional to A minimum square. So which is proportional to A1 minus A2 the whole square, which is proportional to A1 square plus A2 square minus 2 A1 A2. Once again it is proportional to what? I1, okay, plus I2 minus 2 into square root of I1 into I2. Okay, once again these are very important only for the competitive exams. Now once again what will be the special case? Okay, I am going to consider a special case where A1 is equal to A2 is equal to A. That means both the waves emitted by the source S1 as well as S2 have the same amplitude. So in that case, if A1 is equal to A2 is equal to A, then intensity I1 is equal to I2, which is equal to I0, and it is proportional to what? A square. So I0 is proportional to A square. Understand? So I am going to write here. So now you can see that the resultant intensity, I am going to write here the resultant intensity is given by I is proportional to capital A square. So here A is the resultant amplitude. So the resultant amplitude A already is equal to square root of A1 square plus A2 square plus 2A1 A2 into cos phi. This is a general expression for the resultant amplitude. So here I am going to substitute A1 is equal to A2 is equal to A as a special case. So this is now equal to square root of A square plus 2A into A cos phi. So this is once again equal to square root of A square plus A square is 2A square plus 2A into A is again 2A square into cos phi. So 2A square is a common factor. So this is now equal to square root of 2A square into 1 plus cos phi. Now the trigonometric identity we have studied, 1 plus cos theta means it is equal to 2 cos square theta by 2. So like that 1 plus cos phi can be reduced as okay. So 2A square into 1 plus cos phi is also equal to 2 into cos square of phi by 2. So 2 into cos square phi by 2. So that this 2 into 2 will become 4A square. So this is equal to square root of 4A square into cos square of phi by 2. So I have used the trigonometric identity and I have got this. Now this 4A square inside the square root, when it comes out it will become 2A. So that this is equal to 2A into this cos square phi, when it comes out of the square root, it will become cos of phi by 2. So this is 2a into cos of phi by 2. Therefore amplitude. So this is the resultant amplitude. So this can be taken as equation 4. Now the intensity is directly proportional to the amplitude square. You can see here I is proportional to a square, is it not? So the resultant intensity I is proportional to a square, that is proportional to 2a into cos phi by 2 the whole square. So this is I proportional to 4a square into cos square phi by 2. Now already you see that I naught is proportional to a square. So in this a square term is there. Therefore this I is now equal to 4 times I0. We have already written in the previous equations. I1 is equal to I2 is equal to I0 is proportional to a square. So instead of this proportionality a square, I can substitute I naught. So that the resultant intensity I is now equal to 4 times I naught into cos square phi by 2 into cos square phi by 2. Okay, so this is again very important equation. So I number this as equation 5. So this will be the resultant intensity. Now the resultant intensity will be maximum during constructive interference. So what is the expression I am going to derive? So for constructive interference, okay, for constructive interference, so this will be what cos square phi by 2, okay, so that equal to 1. So cos square phi by 2 also is equal to 1 only. Therefore what I maximum is equal to 4 times I naught. So this is 4 times I naught. So next condition is for destructive interference. So the destructive interference, why this term is equal to plus 1? Already I have told you that because phi is equal to 0 are even multiples of pi. Therefore this term is equal to 1. Similarly for destructive interference, okay, phi is equal to odd multiples of pi. So plus or minus pi, plus or minus 3 pi, like that, plus or minus 5 pi. Therefore what is this bracketed term? Cos square phi by 2 will be equal to 0. Therefore I minimum, okay, I minimum is equal to 0. So if you multiply this 4 I naught with 0 means this will become 0. So for constructive interference, the intensity is maximum and that is equal to 4 times I naught. And for destructive interference, the intensity is minimum and that is equal to 0. This is a special case when both the amplitudes A1 and A2 are equal. Have you understood?